While AMD's hardware has been hit and miss over the last few years when it comes to performance and stability, with the 6000 series being mostly excellent, while the 5000 and 7000 series leaving much to be desired, one thing that has remained constant is AMD's lackluster drivers. Driver optimization is no easy task, especially with limited resources, as is the case with AMD's Radeon group, but it seems that could be about to change. Thanks to AI, the days of waiting a couple of years for AMD hardware to reach full potential could be gone, and perhaps AMD can finally start competing with nvidia from day one of release. As you're about to see, AI could in fact be crucial to AMD's GPU strategy. Today's video is sponsored by Urcdkeys.com. If you buy a retail Windows 10 key, you'll probably spend $100 or more. But if you buy an OEM key using a service like Urcdkeys, it will cost you less than $15 after you use the coupon code C25. The keys work globally, and if you want Windows 11, what I recommend you do is just buy Windows 10 and get a free upgrade while you can. Personally, I use Windows 10 Pro. Once you've made your purchase using one of the many different payment options available, you will instantly find your key in your purchased orders on the Urcdkeys website. Click Get Keys and copy the key. Then, after you've installed Windows, of course, press Start and search for Activate and click on Activation Settings. Then click Change Product Key, paste in the key and click Next. That's it. Quick and easy and cheap, and your Windows 10 is now activated. If you need Office 2021 Professional, you can use the same 25% discount code C25 and get it for just $59.98. Since you're over there, check out the Black Friday sale for some great discounts on peripherals like lightweight gaming mice and controllers and some very affordable 60% mechanical keyboards. Thank you to Urcdkeys for sponsoring today's video. Check the links in the video description to get your OEM Windows keys today. If you're an AMD buyer, you will be familiar with the myriad of quirks that come with Radeon GPUs, from random driver crashes to flickering screens, black screens, you name it. It seems that with every fix, AMD engineers introduce new bugs, leaving AMD fans frustrated. As with any other software optimization effort, AMD's engineers exhaustively search for driver code optimizations through trial and error, and with each generation of hardware, more complexity is introduced, as with the case of RDNA 3's chiplets architecture, which left 7900's buyers waiting for 3 months for updated drivers after launch. Now you might think, if nvidia can do it, why can't AMD? It's a numbers game, really. Let's say you are hungry and you are walking down the street and see 2 restaurants, one next to the other. Unfortunately, your phone ran out of battery, so looking up reviews is not an option. One of the restaurants has a long line of people waiting to get in, the other has no line. You assume the one with the long line will have better food, seeing as so many people are wanting to get in, so you join the line. But perhaps the empty restaurant actually had better food. There's no way of knowing for sure without trying both out. Something that would make no sense, as once you've eaten, well, you're not hungry anymore. That's the problem with heuristics. When there are too many data points to analyze, we have to make assumptions to get the best results in the shortest amount of time with the limited information we can gather. While nvidia can have many more engineers min-maxing compiler adjustments, AMD has to resort to hard-coded heuristics more extensively, which often leads to errors. Hence the traditional fix one bug, add 5 new bugs that we've seen from Team Red. Read their driver notes if you don't believe me. Well, it seems AMD has found a solution to this, as discovered by former Cortex collaborator Underfox on Twitter in an AMD patent application. AMD researchers have developed a compiler auto-tuning framework which uses reinforced learning to deploy trained models as heuristics in production compilers. In other words, the trial and error work that AMD engineers had to do to maximize performance can now be done automatically and continuously using artificial intelligence. Changes are made to the compiler, and then benchmarks are ran, and then data is collected to analyze the performance changes. Looking at some preliminary preliminary results using the Radeon 6800 XT as an example, we can see that in a couple of games there was an incredible 15% uplift in frame rate, while the vast majority of games had a 1 to 5% uplift. If you think this is not that significant, remember that the framework was tested against the very mature drivers for the 6000 series, and it still achieved uplifts across the board. The main goal here is reducing the time it takes for AMD hardware to reach its full potential, which sometimes takes years of software optimizations. This could mean that in the next generation of hardware, AMD could come out of the gates with their drivers already maxing out the hardware. This is crucial as the consumer's perception of a product is greatly influenced at the time of the initial reviews. You only get one chance to make a great first impression, and AMD has generally failed at this. But using this DNN framework, AMD could start getting much better initial review results versus nvidia. Perhaps now they can stop lying in their hardware presentations when it comes to performance metrics and actually deliver confident projections that later match reviewers' numbers. Don't underestimate how important this could be for the future of Radeon. There is a catch, however. Patenting code, and especially AI-related stuff, is very difficult. It's a relatively novel field with exponentially new patent applications that a lot of the time conflict with existing ones in some form. In addition to that, nvidia also has a patent application with a proposed neural network-based driver optimization, although taking a slightly different approach. nvidia's method aims to add a neural network subsystem to the GPU control unit, the inputs for which are the application state, the current operating parameter state, and driver cues. So in real time, as a game is being ran, performance is monitored and the neural network responds by updating the operation parameters. In simple terms, the internals of the GPU are tuned in real time to match the best values that come from monitoring performance. So for instance, are there many memory requests being done? Let's optimize the GPU to better match that need. Or is the memory system bandwidth utilization a problem for this particular part of this open world game? Let's optimize the GPU for that. Or maybe the cache hit rates are a problem, or the instructions per clock for one or more threads in an unoptimized game, etc. The driver cues can then be used to modify GPU parameters on the fly, like the clock speed, or enabling or disabling tile caching, etc. Knowing NVIDIA's work with DLSS, we can assume that some additional training work would be done offline on a per-game basis. And from this, we can also speculate that NVIDIA will be adding additional fixed point or integer capabilities to their next generation of hardware, as these would be required for such a control unit to work without a performance penalty in other areas. Of course, tensor cores are already a thing, and those will be used for the real-time processing of inputs. So is NVIDIA's approach better or AMD's? It's not about being better or worse. There are many ways to skin a cat. It's about using software to maximize the hardware. As with most AI applications, the companies with the least resources benefit the most. So while NVIDIA will surely achieve further performance gains using AI, AMD stands to gain the most, as they have less engineers to hard-code heuristics. Hopefully, AI can bring the two companies closer together when it comes to performance and put an end to AMD's long history of driver issues. There are many other ways in which AI will be transforming the semiconductor world, and I will continue covering them in future videos. Make sure you're subscribed so you don't miss that. This video was made possible by my awesome patrons. By supporting my channel on Patreon, you will gain access to the Cortex Discord server, where you can talk to me directly and join a welcoming community of tech enthusiasts. If you can't contribute at this time, then give this video a like and share it, as that really helps. Thanks for watching, and until the next one.